All right, we're going to go ahead and get started. And we're asked to find the cosine of 13 pi over 12 using the half angle formulas. So if we refer to the formula sheet, give me 1 second, I'm going to bring that up. All right, under our half number identities, we see here is the half angle for cosine, and it says that the cosine of a over 2 is equal to plus or minus the square root of 1 plus cosine a divided by 2, right? So that's the formula that we're going to use. All right, so if I were to change, let's see, 13 pi over 12 to an angle measure, excuse me, to a degree measure, I have 13 times 180 and that's a 12 divided by 12. Right, and that gives me 195 degrees. All right, and I'm asked to use a half angle formula. Now, if I look in the unit circle, I see that there is not a 195 degree angle, right? So here's the trick I'm going to play on this. Now, normally in the example that I showed before we left, we were able to take an angle that was in the unit circle and kind of cut that angle in half, all right, because these angles in the unit circle, they run from 360 degrees. What I'm going to do in this case is I'm going to take the 195 degree angle, which we have, right, and I'm actually going to double it. I'm going to multiply it times 2, and I get 390 degrees. All right, so I'm going to write this as the cosine of 390 degrees divided by 2. Right. So you also notice that 390 degrees, it's, if I go back to unit circle, it's not actually in the unit circle. However, I could find its coterminal sister that would put it in the unit circle. All right, so what I mean by that is if I have 390 degrees, I'm going to subtract 360. And I see that 390 degrees and 30 degrees are coterminal, right? They start at the same spot and they end at the same spot. So I don't actually have 390 degrees in my unit circle, but I do have 30 degrees, right? So the cosine of 30 degrees would in fact be the same as the cosine of 390 degrees. All right, so above the cosine of 390 divided by 2, I'm going to write the formula for the half angle for cosine. So the cosine of a over 2, right? So we've established the fact that a is 390 degrees. That's equal to plus or minus times the square root of 1 plus cosine a divided by 2. All right, so here the first thing we must do is establish the sign. Okay. So now we're actually trying to find the sine of, we're actually trying to find the sine of the cosine of 190 degrees. Right? So if I just draw out a rough sketch, and we have 0 degrees here, 90 here, 180 here, 270, and then one complete rotation is 360. Remember, from our reference angle, all students take courses, right? These gives us the sines of the 6 trig functions in each 4 of the quadrants. So notice that a 195 degree angle would lie in the 3rd quadrant. Okay. Right, so if our angle is in the 3rd quadrant, the only positive values are the tangent and the cotangent. Everything else is negative. So the first thing I'm going to do is establish my sine. So the cosine of 195 degrees, it should be negative. Right? So the first thing you want to do is establish your sine based upon the angle that you're actually trying to find. Right? So we've established the sine. So that should equal to a negative times 1 plus the cosine of A, right? So keep in mind that A in this case is 390. We've already established the fact that 390 degrees and 30 degrees are coterminal angles. So I'm going to put an extra step in here. So I'm actually going to use the cosine of 30 degrees divided by 2. So that's equal to the negative times the square root of 1 plus, and if I look within my unit circle, I see that the cosine of 30 degrees is square root of 3 over 2. Divided by 2. Now I was kind of looking at some of the problems and the way that I worked the problem out in the last class was sort of different than what I actually seen on the viewing example. So I'll kind of show 2 ways on how to work this. This is what I did in the last class. I got rid of the fraction in the numerator, right? So I multiplied the numerator and the denominator by 2. 2 over 2, right? 2 over 2 is a special form of 1. The next thing I did was I distributed 2 in the top and in the bottom. So 1 times 2 is 2. The square root of 3 divided by 2 times 2 gives me the square root of 3. In the denominator, 2 times 2 is 4. Right. Then I believe we use the quotient rule for radicals. So we have negative square root of 2 plus the square root of 3 over 2. Right. Now looking at the homework problems, right, they worked it out sort of differently. So I'm actually going to take it from this step here. So this was negative times the square root of 1 plus the square root of 3 over 2 over 2. Okay, so they kind of left everything in the square root. Okay, so just to show the solution that they're getting. From this point, I believe they used the divide by a monomial. Formula, and it says that A plus B over C, that's equal to A over C plus B over C. Right, so that divide by a monomial was applied here, so I have 1/2 plus the square root of 3 divided by 2 all over, and I'm going to write this as 2 over 1, right? So this is all within the square root. Just make this look a little bit better. Right? So this is a negative times the square root of 1/2. And then there was another formula that we talked about, A over B all over C over D. That's equal to A times D over B times C. So you can multiply the very top and the very bottom. So the square root of 3 times 1 is the square root of 3. And then 2 times 2 is 4. All right, so you sort of seen a solution that looks something like that as far as the problems are concerned, but they will accept both of these solutions. All right, so any questions about this problem?